Now let's look at set theory part 3. The part 3 of set theory. We have done part 1 and part 2. If you have not watched, go and watch part 1 and part 2. Now we are going into 3 sets. 3 sets. You can see we have set X, the first one, Y, the second one, and Z, the third one. Your own might be P, Q, R, might be A, B, and C. But this is X, Y, and Z. So 3 sets. We have done 2 sets in the previous class. Go and watch it. Now, we have set builders form. You know what's called set builders? Set builders form is they will give you some notations. You understand? Like what we have here. See. So they will now ask you to use that notation form to build out your own set like this, to make it something like this, just numbers like this. You understand? That set builders form. So this one too, you are given a word problem, so you will try to think, you interpret what we have here, so that you can get your normal, set form like this. So that's what we are trying to do. Okay, so let's look at it. Given that our don't forget that this is symbol of universal set, or that is universal set. Don't forget it. So equals to this 1, 2, 3 up to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 15. So x equals to this. Let me break it down for you. So 2x plus 1 such that x equals to, this bracket means is a set of numbers. Let's say these numbers like this set of numbers. Everything here will later give us a set of numbers. Understand now? So 2x plus 1 such that x, you can see x is here. We are looking for this, but x is here. So that x is around 2 to 6. That's the meaning. The x is around 2. Let's say 2, 3, 4, 5, 6. From 2 to 6. But you have to take note. Now, listen. You know what this means? It means the next whole number after 2 is 3. So 2, 3, 4, 5, and 6. So there is no, you can see the 2 signs here. This one is less than, this is less than or equal to. So after 2 is 3. So 2 is less than 3. The next number after 2 is 3. So 2 is less than x, that's 3. So 2 is less than 3. So we are starting x with 3. So 3, 4, 5, 6. Are we going to write 6? Because of this equal to here, we are going to write 6. Assuming there is no equals to here, we would have said 3, 4, 5. Stop in 5 because 5 is less than 6. That's what I mean now. But because this symbol is there, we will stop in 6. Assuming this symbol is here, we would have started with 2 because of equals to 2. So that's 2, 3, 4, 5, 6. All together. But the symbol is not there. That means we are starting with 3 because 2 is less than 3. So that means we have, after 2 is what? 3, 4, 5, and 6. Hope you get that. So now that means our x is equals to either of these. X equals to, that means the x is either is 3, or x is 4, or x is 5, or x is 6. So we now start to bring it out now. That means our set x here is equal to what? Let's see. Now we just begin to fix your x one by one. When x is 3, put your 3 here. That's 2 times 3. That's 6. 6 plus 1 is what? Is 7. That's the first one. When x is 4, let's see. When x is 4, put your 4 here. 2 times 4 is 8. 8 plus 1 is 9. You can see. Now 5. When x is 5, 2 times 5 is 10. 10 plus 1 is 11. You can see. Now 6. 6. 2 times 6, 12. 12 plus 1 is 13. You can see. We have formed our own set. You can see. So I mean x equals 7, 9, 11, and 13. Hope you get that. You can see the way we form it. Very simple and easy. Very simple and interesting. So that's for set x. Set y has been given before normally. Let us also think about, let's break down this. Z equals to, let's see, set z equals to what? Let's see what's happening. Odd numbers. Make sure anything you think about must be within this model, the elements in the model, the universal set. Don't go outside it. So odd number. What are odd numbers? Odd numbers are numbers that end in 1, 3, 5, 7, and 9. We have odd number and even number from our small classes. You understand now? Notice. If we have, let's say we have numbers like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is odd number, even number, odd number, even number, odd number, even number, odd number, and so on and so forth. So when your number ends with 1, 3, 5, 7, 9, that's odd number. When your number ends with 2, sorry, there's 0 also. 0, 2, 4, 6, 8, that's even number. Yeah, what are the odd numbers that we have here now? That means we have 1, 3, 5, 7, 9, 11, and 13. So let me list out the odd number now. We have 1, 3, 5, 7, 9, 11, and we have 15 also, 15, because it's up to 15. That's odd number. That are multiples of 3. What are the multiples of 3? Multiples of 3. Multiplication table 3. 3 times 1, 3. 3 times 2, 6, is not there. 3 times 3, 9. 3 times 4, 12. 12 is not there. 3 times 5, 15. These are the multiples of 3. So we have 3, 9, and 15. That is everything here. So everything here means 3, 9, and 15. You can see, very simple and easy. So we have 3, 9, and 15. So 3, 9, and you can see, very simple and easy. So of course, our x is this, our y is here, and our z is this. Please make sure you subscribe to my YouTube channel. Press subscribe as you are watching it. Try and share my video to anybody in the world. Like my video and drop a positive comment. Don't forget that. Understand? Okay. So since we have broken down all these self-builders form, then we can now start to solve what we have here. We are asked to find what? Number 1, x intersection this. It's very simple and easy. Very simple. Just focus on the bracket. What do we have in an enclosed bracket? Do that one first. We have this in an enclosed bracket. Do it first. Y intersection z. Do it first. Let's do it first. Our y intersection z is what? Don't forget that intersection means the common thing that is common to y and z. Go and check y and z. My y, my z. So what is common to y and to z? Let's check. What can you see that's common? 3 is there? No, 3 is not. That's 9. I think we only have 9. 9 is the one that's only common to 1. So that's 9. We have 9 here. You can see. That means everything here is 9. It's 9. You understand me now? So now, where's your x? Your x is where? This is my x here. My x. So x intersection, what you just got now? Where's my x? My x is this. Where does x intersect? All this means one single thing, which is here. This. So where does x intersect this? Where does x intersect this? So what's the intersection here? That's 9 and 9. 9. So our answer is 9. That means our result is 9. So that means our x intersection y intersection z is equals to set of numbers 9. As simple as A, B, C. You can see. Very easy. Now let's look at the second one. Now, this second one, you remember there are some laws, some rules that guide sets. You understand me now? There is a law that we call distributive property. Distributive law or distributive. When I say distribute, let me break it down for you. When I say distribute, let me break it down for you. Now, let's say we have something like this. Where's my dust storage? Let's say we have something like this. Please permit me to clean this topic so I can understand better. Let's say we have something like this in maths. If you have 3 into brackets, let's say we have 5 plus 6 plus 7. What is that going to be? Let's do it normally. So that's going to be 3 into bracket. 5 plus 6 is 11. 11 plus 7 is 18. So that's 3 times 18, that's 54. Now we can also do it this way. We can distribute, share. So this 3 is outside. We have all these numbers inside. So 3 will distribute to 5, distribute to 6, distribute to 7, following the operations. So let's see. Bracket means times. 3 times 5 is 15, plus 3 times 6 is 18, plus 3 times 7 is 21. If you add everything, let's add this plus this, that's 33 plus 21. We still get the same 54. You can see Very simple and easy. So the same thing is happening here. Look at it here. If you have something like this, you have something like this, you have this, you have x intersection y intersection z. Oh, sorry, please, excuse me, this one should be intersection. Sorry for that. Intersection. Sorry. You can change intersection. Change it. So let's see. Your answer is going to be what? Very simple. So x is the one outside, which is operation. Distributing to two of them, you can see. So x, this one distribute to y. That's x union y. X union y. You can see that's for that. Then this is the operation. We put in the intersection. That's connector. Then this one also comes to z. So x intersection comes to z. That's x intersection z. It's inside its own bracket. You can see. This is what we call distributive property. You can see. Let's assume what we have here is union. Then this one could have been union. You know what I mean now? It would have been because this is x union, x intersection y is here. Union is the connector. Then x intersection z is here. You can see, very simple and easy. Now look at this question 1 and question 2. I will not even do this one at all. I will just apply the law because the two of them are the same. Check, they are the same. Check it out. X intersection y, the intersection, the x intersection z. So the same. So I will just say what I have here is equal to what I got here, and that is T9. So that's my result. Very simple and easy. That's my question 2. So question 2 is my question 1. Question 2 is what? This, I have my x intersection y intersection what? X intersection z is equals to what? It's equals to 9. You can say it's equal to what I got here. That they are the same thing, which they are all equals to the set 9. By what? By the distributive property. By the distributive, you understand what I mean now? Distributive property. You can see, very simple and easy. That's it. Very simple. So master distributive. Don't forget that in my first video in the part 2 of this set, I explained De Morgan's rule. You remember that? De Morgan's rule. Go and master all those rules. You understand me now? Master it. So that's for that. Now let's look at question 3. Number 3. Not to waste time. Number 3. Okay. Now let's see. X, like I told you, anything you have inside a bracket, it means only one. You understand me? Identity. Just one. It means one identity. Just one. Like everything inside here means only one identity. So you have to first of all go and do this one, get an answer for it, then do the second one too, get the answer. We now find an intersection between the two. So get this one out, find the intersection. Let's find this one first. So let's find we have number 3. Let's find our x intersection y prime. Let's see. So firstly focus on the one inside the bracket, x intersection y. It has been done before. Where is it? Okay? We have not done it before. Let's go and find it. It's very simple now. Where does x intersect y? Let's check quickly. Where does x and y intersect? Let's check quickly. Where does x and y intersect? Let's check. What's common number there? We have 9. We have 7 is there. 7 and 9. So this is 7 and 9. 7 and 9 normally. You understand me now? That's this set here. Don't forget that. And I told you that this prime means what is not there, what is not here, but it's in the mother. The mother is from 1 to 15. That's the universal set. So just exclude this 7 and 9. The remaining one is the result. So that's what? That's 1, 2, 3, 4, 5, 6. Exclude this 7, then write your 8, exclude your 9, so we have 10, 11, 12, 13, 14, and that's my first one here. This one here, you can see. So the remaining second one is Z prime. So let's find out Z complement. That's what? Like I told you, prime means what you cannot see in that Z. Where is Z? Find your Z first. My Z is here. So the prime means what is outside this Z that you cannot see here, but you can see the mother. So that's what? That's 1, 2. So now 1, 2, 1, 2. Exclude the 3. Then we have 4, 5, 6, 7, 8. 4, 5. You understand what I mean now? 6, 7, 8. Okay. Exclude your 9. So now like 10, 11, 12, 13, and 14. You can see. So the first one has been done. Hope you get it. The second one has been done. So the first one has been done. The second one has been done. So just find the intersection, common thing between the first one and the second one. So let's find the common thing here and here. So that's what. What's common to this and to this. Let's check. 1 is here, 1, 2. So let's see 1, 2. We have 4. We have 5. You can see 5, We have 6. We have 8. We have 10. We have 11, 12, 13, and 14. So this is my results. That's my results for this. That's very simple and easy. Now the next one is what? X intersection Y intersection Z. So let's double click. Let me clean. Hope you have written this one. Hope you have understood. Let me clean it. Let me clean so that I have more space to write my work. So let's look at the last two. You can see that this topic is very easy and simple. Very, very easy and simple. So let's look at the number what? Number 4. So let's see. X intersection Y intersection Z. What does that mean? The intersection, where does X intersect Y, intersect Z? As in X, check your X, the first one, check your Y, the second one, check your Z, the third one. So where do the 3 of them what's the common number that can be found in X, can be found in Y, and can be found in Z? All the 3. Let's check. X is there, Y is there, and Z is there, all the 3. So what can you see here, here, and here? Check very well. 7 is here. In X, 7 is here, but 7 is not here. We can't take 7. 9 is here, 9 is here, and 9 is here. It's in the 3. So we'll take 9. What else? 11 is here. 11 is not here. 11 is not here. I think that's the 13 is here. 13 is also, my answer is what? Is 9. You can see that's the intersection between the 3. And last one, that's X union Y union Z. Let's say this one. This will be long because union means everything together. Write everything out. What you can see in X, what you can see in Y, and what you can see in Z. Write them out all together. But you have to be careful. X, we have this. Y, we have this. Z. So write them out. Start from the lowest. Let's see. So 3 is that 3 is the first one. So we start with 3 because 3 is 4 is higher. 7 is higher, so start with 3. So we have 3. After 3 should be what? 4, 5. 4, 5. You have 6. No 6. Then 7. Because 7 is there, so 7. 8, 9. Once you're writing this one, you don't have to bother order. Since there are 7, 8, 9, they are one after the other. 9. Then let's see 10. No 10. Then we have 11. We have 11. No 12. We have 13. No 14. Then we have 15. So that's the result. That's the union of everything. Hope you understand it. So I want you to calm down, relax, and to try and sit down in the corner and then look at it very well. It's very simple and easy. Once again, welcome to Mr. Bams Honest Labs. Don't forget to like my video, drop your positive comment, share my video, and then subscribe to my channel. Thank you. So I will do the next class later. Just stay tuned with me. Thank you.